All right, so what are we doing today?
Pretty much the same thing. Just trying to review for my quiz.
Okay,
So,
do you have some problems?
yes, I do.
Okay, let's do them.
First one I have is sine x equals -4/5. And
Negative
then
4 over root 5.
over normal 5, no root.
Okay,
Then it has like the bracket telling me which quadrant it's in, which is pi, comma, 3 pi/2,
which quadrant is that?
the third quadrant.
Okay,
Then it's sine 2 theta equals what? That's pretty much then.
all right. So what's the sine of 2 theta equal to according to the double angle formula?
Using the formula yesterday,
Hmm. Yeah,
if I remember correctly, sine or 2 sine times 2 cosine.
no, just cosine.
Okay,
So it's sine cosine.
okay.
Okay, and we know what the sine is, but we don't know what the cosine is. So what's the cosine of theta or x?
So what I'd have to do is draw a triangle to help figure that out. And so plateau. So the opposite will be -4.
Well,
And
you know what? Let's dispense with the plus or minus sign. We don't need the plus or minus sign until we get done.
yes.
Okay? So this side is just 4, that side is just 5. In other words, I'm going to do everything as if it was a first quadrant angle.
Okay. And then we added it later.
Yeah, and then when you get to the end, you know the cosine of theta has to be negative in the third quadrant, so whatever number you come up with, you just put a negative sign in front of it.
Okay.
So what's the base of this triangle?
3.
So what's the cosine of theta equal to?
3/5.
And it's sine. It's plus or minus sine. The third quadrant.
It is minus. Only tangent's positive.
Right. So both sine and cosine are going to be negative. Okay.
Yes.
We got -4/5, -3/5. So what's the sine of 2 theta equal to?
So then it would be 2 times -4/5 times 3/5. And that would be 8/5 times.
-3/5.
Yes.
Both of them are negative, and that's important.
Then it will be -24/25.
It's positive.
You're positive, yeah.
Because I have a negative times a negative. That's why I was so
adamant.
In other words, all of math, you cannot afford to drop a negative sign. I mean, you might get lucky and drop 2 of them, and then you'll have the right answer. But most of the time, if you do not pay attention to your signs, you will get the wrong answer. So the sign is as important as the number.
Okay.
Okay? So that's what the sine of 2 theta is equal to. All right, what else?
Okay, then the next one I have is sine x equals -4/5. And then it's in the third quadrant again.
Okay.
And then it's find cosine 2 theta.
They want the cosine of 2 theta?
Yes.
Which identity should we use?
Um,
There's 3 of them. What are they? Each one. Tell me the first one.
the one that I do remember, that I always use almost, is, I believe it's cosine squared minus sine squared.
That's the first one, and that's the one I always remember also. And the reason that's fairly easy to remember is that we know cosine squared plus sine squared is equal to 1. So it's not that. So it's cosine squared minus sine squared. And then the other two, one of them has nothing but sine squared and the other has nothing but cosine squared. Which is which?
There's, looking at my notes from yesterday, it's 2 cosine squared minus 1.
All right. So that's one of them. They're all minus, notice, minus, minus. What's this one? It's kind of the reverse of this, and which would make it 1 minus 2 sine squared. Okay, so however you want to memorize that, you can memorize it as they both have negative signs. The first one has cosine squared first, the second one has sine squared last, and they both have a 2 in front of the trig function.
Okay.
So this is not that easy to memorize. I've spent years doing it, and I occasionally still have to look at the book. But you know, trig is all about memorization, and anything you can use to make it easier, you should use. You know, we all have tricks for memorizing stuff, but it's which one should we use?
2 cosine squared minus 1.
We don't know what cosine squared is.
Can we use a triangle?
Well, we could, but that would be an extra step. Why don't we just use this one? Because they've already given us what sine of x is.
True.
You see what I'm saying?
Yes.
In other words, we could use any of the three, but if we're trying to do it in the least possible steps, we want to use the one that they've already given us, which is sine of x. So we're going to use this. So what's that?
Okay, so 1 minus 2 times negative 4 over 5. So
hold on.
So now,
it's 1 minus 2 times negative 4 over 5 quantity squared. Look at that identity. It's 1 minus 2 sine squared of theta. Well, they've told us the sine of theta is equal to minus 4/5. So we're just going to take that minus 4/5 and square it.
Okay.
See?
Yes. So then that would be 16 over 25.
Well, let's see. What is that? 1 minus 2. That becomes positive. In other words, when you square a negative, it becomes positive. So now it's 1 minus 32 25ths, which is minus 7 25ths. There's your answer. Now, can we get an idea of whether we have the right sign or not? Now, we're in the third quadrant, but it's asking about the sine of 2 theta. So that's hard because if you're in the third quadrant to start with, the sine of 2 theta could be in the first, it could be in the second. Both of them are positive. Hold on, we got a negative answer. Oh, we were solving for the cosine of 2 theta.
Yeah.
And if theta is in the third, the cosine of 2 theta could easily be in the second quadrant. You see how? In other words, if I'm looking at an angle that is like that, in other words, I'm in the third quadrant, multiply that angle by 2, and you end back up in the second quadrant. And cosine is negative in the second quadrant. So the fact that our answer is negative 7 over 25 Makes a lot of sense.
Okay.
Okay, what else do we have?
I have sine 2x minus sine x equals 0.
Sine of what x?
Sine 2x minus sine x equals 0.
Okay. Well, we got the same trig function, but we don't have the same angle. So what do I have to do?
Can I factor out?
Not yet. In other words, there's nothing you can factor out if I have sine of one angle minus sine of a different angle.
True.
So let's use the double angle formula for that. And then what do we have?
Let me think. Sine 2x.
This is the easiest one. Always starts with 2.
I remember doing this, but I completely lost my train of thought at the moment.
That's what sine of 2 theta is.
Okay.
Okay. Now you'll notice we can factor out something, and after we do, we're going to have the product of two things equals 0, which is exactly what we need in order to solve it. So what can I factor out?
Sine.
What's left over?
2 cosine x equals 0.
No. What's the rest of it? Remember, when you factor something out, you have to divide both terms. You have to divide that term, and you have to divide that term.
So minus 1.
Okay. That's key. And, you know, whenever you're factoring out a greatest common factor, which is all we did here, it's always a good idea to multiply them back together again. Make sure you got the same thing you started with.
Mm-hmm.
That will really help with errors. In other words, if you're prone to errors, then just always do the check. Always multiply this times that and this times that and see if you get this. You kind of do it as you go along. In other words, when I write 2 cosine of x there, in my head, I'm multiplying that by sine x to make sure I get this. I do the check right then. I don't wait until I'm done.
Okay.
Then when I do this number, minus 1, I'm checking, is that the same thing? Minus sine x. Well, yes, it is. So now I know I did it correctly. Now what can I say at this point?
Sine x equals 0. Your sine equals 0.
Or,
Then that means theta will be pi 0.
okay, or
Or cosine equals 1 over 2.
which means x is where?
Pi over 3 and 5 pi over 3.
So you have 4 solutions.
Yes.
And that's kind of what you would expect, because you have a quadratic. Okay, well, usually trig functions give you 2 solutions in the unit circle, right? I mean, if I say sine of x is equal to 1/2, you know, well, that's first quadrant and second quadrant. Well, when I have something that's like a quadratic, I would expect 2 solutions, but with trig, I would expect 4 solutions. And indeed, I do have 4 solutions. All right. What else?
I have sine 2x minus cosine x equals 0.
First step? given the chapter we're on?
Let me think. Sine 2x. Could I turn it into sine
What's
theta cosine
the
theta?
identity of that? There's only one.
Oh, then it would be the identity is sine.
Hold on. We just used it. It was this one right here.
2 sine x and cosine x.
2 sine x cosine x. In other words, when you're thinking of sine of 2x, you're always going to begin with 2. And then the rest of it kind of makes a little bit of sense, but that's what it is.
And then cosine of the big 3. Okay.
Okay. What's the next step?
Next step, I can factor out cosine.
What do you have left?
I'll have 2 sine minus 1.
Next step.
Then I'll do the same thing, cosine equals 0. Then sine equals 1 over 2. That's the same answer we got last time?
I don't think so. What's the x going to be when cosine x equals 0?
X is going to be, oh, yeah, it's not the same. Pi over 2 and 3 pi over 2.
Right. And how about sine x equals a half? Where?
5 pi over 6 and pi over 6.
Curious as to how you started in the fourth quarter.
Say again?
I'm curious as to why your first answer was from the fourth quadrant. In other words, normally when I'm doing this problem, I figure out what the first quadrant answer is.
I just go around whichever is quicker to mine.
Ah, okay. Yeah, I'm not saying you're wrong. I was just curious. It wasn't fourth, it was second. Sorry. In other words, you went second quadrant, first quadrant. Rather than first quadrant, second quadrant. And I was just curious as to what's going on as to why you would go in that direction. Why?
It's kind of a weird way how I memorize it. For the unit circle, whenever I look at the outside functions, I do 1, 2, 3.
Okay.
Then 1, 2, 3.
All right.
And then after that, I think of it, and then I put a square root over everything that's not a 1.
Mm-hmm.
And then I think, and then whichever just comes to mind quickest.
Okay. Yeah, well, that's like I said, we all memorize stuff in different manners, and whatever works for you is what you should use. What else you got?
I have sine 2x plus 2 cosine x.
Equals?
0.
Okay. What's the identity for sine of 2x?
Could I do cosine squared and sine squared?
There's only one identity for that.
Oh, wait, hold on. Cosine and sine times 2.
Times 2. Always start it with a 2. It'll make it easier to memorize.
Okay.
In other words, that's sine of 2x. And there's only one. Okay, now, what can I factor out?
Can I factor out 2?
2 what?
2 cosine.
What's left?
Sine and 1 plus 1.
Plus 1.
Equals 0.
Which means...
So then, that would be sine, so minus 1, and sine equals negative
You like to work from right to left also. What the heck?
I don't know. Whichever seems this easier to me, I just go with. Whichever I can
go left to right, and I go quadrant 1, quadrant 2, quadrant 3, quadrant 4. And you go backwards of that, which I'm curious about. It doesn't matter. Don't get me wrong.
This is
Don't get me
different.
wrong.
I
It's fine.
understand.
I'm just more curious about it than anything. So what's x equal to if sine x equals minus 1?
Then it would equal sine x. It would equal only at 3 pi over 2.
Okay. And the other possibility?
Other possibility, 2 cosine x equals 0. Divide everything by 2. And so 0 divided by 2 is 0, right?
Uh-huh.
And then
In other words,
x
it's the
equals
same
0.
problem as this. Okay.
So where cosine is 0 is pi over 2 and 3 pi over 2.
Ooh, this is kind of interesting.
Yeah, I've never seen it that way
I've
before.
never seen it either. I've never seen where there's two answers that are the same. Did we do this one right? Let's see. Sine looks like that. And that's where it's minus 1. So that's definitely 3 pi over 2. Cosine looks like this. And that's 0 right there at pi over 2 and 3 pi over 2. All right.
It's just weird.
Yeah, it is kind of. Yeah, just because I've never seen it doesn't mean it can't be so. So I guess there's only two answers. Those two right there.
Cool. Learn something new every day.
What's that?
I said we learn something new every day.
That's right. You do, actually, in math. It's amazing how often I see stuff that I've been tutoring for 7 years, and I still see stuff at least once a week that I've never seen before.
Next one I have is cosine 2x plus 2 equals -4 cosine x minus 2 cosine squared x.
Oh, minus 2 cosine squared x. Okay.
Should I add everything on the right side to the left side?
No, the first thing to notice here is that we have cosine x, cosine squared x, but we have cosine of 2x.
So I can get rid of 2's.
Well, we want to change everything into x, not 2x's. So what identity should I use for cosine of 2x? You got 3 of them.
Let me think.
I could use cosine squared minus sine squared.
There's 2 cosine squared minus 1 as well.
That's the best one. Why?
Okay.
Because now I have everything in cosine x. In other words, once you get everything in cosine x, now you can apply the quadratic to it. I don't have multiple trig functions. Okay? And in fact, I got 2 cosine squared x there and minus, oops, no, I got to add that. So what's the next line? Whenever you see a quadratic,
a -1 and the +2 combine like terms?
well, not just combine like terms, but we get everything on one side and 0 on the other.
So everything on the right I can add to the left?
Yes.
So +4 cosine x and +2 cosine squared x.
And the numbers become +1. Okay. Is that right?
Yes. So now there's 4 cosine squared x and 4 cosine x.
Can you factor that?
I believe so.
There's no greatest common factor, but the next thing to check is whether I can factor it like I would factor a polynomial.
So 2 cosine.
Yeah, and that could be 4 and 1, but I always tell my students to always try the two factors that are closest together first. And 2
Okay.
and 2 are closer together than 4 and 1.
Mm-hmm.
Okay, what must the signs be?
+1.
Does that work? Does that produce a middle term that is our middle term?
So 2 cosine 4 cosine squared x.
Now hold on. The only thing you need to check is the middle term. You don't need to check to make sure that term's right. There's no way we're getting that wrong. Our very first step was to split that up into two things that multiply together to be that. Okay?
Yeah.
There's also no way we're getting that wrong. We knew it was +1 + 1. So the only term that might be in doubt, that you always have to check whenever you're doing quadratics, is the middle term. How do I get the middle term? I get it from multiplying the insides and the outsides. The O and the I of FOIL.
So 2 cosine x plus 2 cosine x is 4 cosine x.
That means we got it right.
And that's the middle term.
That's the middle term. So that's always a step you want to make. You never want to factor a quadratic without doing this step. And in fact, a lot of times when you're factoring quadratics, you kind of have to do this step to come up with the solution. Because sometimes there's lots of choices. This time there weren't very many choices. I mean, we could have used 4 and 1 there, but once we decided on 2 and 2, the only other choices were +1 + 1. So, but a lot of times if you're solving hard quadratics, you need to do this step here in order to determine whether you have the right answer or not.
Okay.
So now what? I know I got it factored, right?
So then I'd have to put it, so then -1. So then 2 cosine x equals -1. Then divided by 2, then it'll be -1/2 equals cosine. And on the unit circle, that would be located at. I'll try and do this one in order this time.
No, don't actually. I mean, I in no way, shape or means meant to question your process. Everybody has their own process. And if that's the way you've always done it, keep doing it that way. I don't see any problems with it. I just found it interesting that you go in the opposite direction that I go.
Like, it's not always the opposite. Like, whatever just seems easier at the time, like, my brain just gets it quicker.
Okay. I
So,
kind of am a believer in doing things the same way every time. In other words, if I ask you to factor a squared minus b squared, what would you say?
I would say a plus b and then a minus b.
See, it makes a lot more sense to memorize it this way.
A minus b and a plus b.
And I'll tell you why. Because when you get to difference of cubes, the first term is always the same sign. The second term is the opposite sign. And when I have sum of cubes, the first term is the same sign. The second term is the opposite sign.
Okay,
so if you're looking for a way to memorize it, notice that the very first term has the same sign in all three cases.
Okay.
If you memorize it a plus b times a minus b, that's not true.
Mm-hmm.
So there's a certain logic to memorizing it a certain way with this. And you could apply that to a lot of things, not just the difference of perfect squares. But a lot of times there is a way to memorize stuff that just makes it easier to retain in memory and do additional stuff also, like different perfect squares is one. And maybe that's the only reason you would want to go in order. In other words, my first step when I'm asked that, what's the first quadrant angle?
-1/2.
Well, if cosine x equals -1/2, what's the first quadrant where cosine x equals 1/2?
Second.
Well, okay. What's the angle is what I meant.
120.
What's the first quadrant angle?
60.
That's what I remember.
Okay.
Okay, and the reason is that's not the answer, but now is all I have to do is because cosine is negative, I know I have to be in the second or third. And now I just have to find the equivalent angle to that that's in the second. Well, there's the second. There's the third. Those are my two answers. You see how I do it? I relate everything to first quadrant to get the angle.
Then you move around.
Well, and then I see that there's a negative sign, so it has to be second or third quadrant.
Oh, yeah.
So I look for the second or third quadrant angle that's the same as 60 degrees.
Okay, because it couldn't be negative in the fourth or the third. Okay, I
Well,
see.
in the fourth, it's positive. Cosine is positive in the fourth.
Yeah, that's what I'm saying. It can't be negative there.
Right.
Yeah.
But the way I do all my trig is to come up with the absolute value number first, and then translate it to whatever quadrant it's in. In other words, I ignore that negative sign at first. Because all I care about is what is cosine x equals 1/2. Well, in the first quadrant, that happens at 60 degrees. But since it's negative, it has to either be the second quadrant or third quadrant, which is the equivalent of 60 degrees is 120. The equivalent of 60 degrees is 240 in the third. And that's just the way I do all my trig. I'm not saying you have to do it that way. To me, that seems to be the easiest way. When you're dealing with the unit circle and you have 4 quadrants, if you can relate everything to first quadrant, it generally makes it a little easier. Okay? All right, Taylor, any other questions?
No, that's it actually. Thank you.
All right, have a good one. Talk to you probably next week.
Sounds good. Talk to you later.
All right.